Now they are asking, determine the magnitude of the force F so that the resultant Fr of the three forces is as small as possible. What is the minimum magnitude of Fr? This one is a little bit difficult one. But if you see this one, you can see that we don't have that many problems in this chapter. But for your understanding, I'm just trying to do that one so that if you see these kinds of problem, then basically you can solve it easily. Okay? So first of all, what I'll do, what they're asking actually. They're asking, like, what's the value of F so that the resultant of all that three forces would be minimum. Okay? So to do that, first of all, I'll try to find out the resultant of these two forces first, because I already know the resultant of these two forces. Okay? So this is your basically resultant. So since this one is 90 degree here, so you can see this one is basically right? You can use, this is from the Pythagoras formula, but if you use the cosine rule, then basically you will see that 8 square plus 6 square minus 2 into 8 into 6 cosine 90. But cosine 90 equal to 0, so basically you will get your r equal to this square plus this square. Okay? The same way you can just do that. Now you can also find out this angle here. Okay? So the angle here, let's say this is theta of the resultant angle that's making with the vertical, or you can just say like, hey, what angle this one is making with the horizontal doesn't matter. So let's say this is alpha. So tan alpha is basically 8 by 6. So alpha is equal to tan inverse which is basically 53.13 degree. Okay? So rather than showing these two forces here, let's say this is my x-axis and this is my y-axis here. I can show, rather than these two forces, I can show only the resultant which is working along here. And this one, this angle is 53.13. Okay? To find out now the resultant of this force and this force, this is actually the resultant of these two, and if you add F with that, then basically you will get the resultant of the three, like forces there, right? So to draw the force triangle for that one, you can see what I have to do. I have to go to here, and then I have to draw a parallel line here. Since this value of f is not given. So it could be here, it could be here, it could be here, right? I don't know. But they gave you a clue that the resultant would be minimum. So the resultant would be something like this, right? So this is your let's say for this one, this is your R1, this is R2 and R3, and I'm trying to see that which one would be minimum. So if you see like R1, R2 and R3, these are the distance from here to this line. So which one would be the minimum? The minimum one would be the perpendicular distance from there, right? So we can say like, well, for minimum resultant, this one should be here, so that this angle is 90 degrees. Okay? So this one is your F, this one is 10, the angle of this one will be how much? You can see this one and this one is parallel, this one is connecting that one, so this angle has to be equal to this angle, right? So this angle is actually 53.13 plus 30 degree, that's actually 83.13 degrees. Okay? So you can see again that I draw that line such a way that R1 is minimum, and that minimum would be only possible when this one is the perpendicular distance from that point to that line, right? So in that situation we can just find out F1 from here. So what would be this angle here? If this is 90 and this is 83.19, so this one has to be 90 minus 83.13, which is basically 6.87 degrees, right? So if you use your sine rule now, then you can just say, let me do that one here. You can say 10 divided sine 90 is equal to F divided by sine 6.87, sorry. So sine 90 is basically 1, so F is equal to 10 sine 6.87, which is 1.2 kilonewton. Similarly, you can find out also the resultant of this one, like use, let's say, 10 divided by sine 90 is equal to R divided by sine 83.13 So R is basically 10 sine 83.13, which is 9.93 kilonewton. Okay, so basically when they are saying that find out your F for the resultant would be minimum, that's actually giving you a clue that the line of the resultant has to be perpendicular on F. Okay, that's the example for this particular method, and in our next video I'll show you how to do that, dissolve the force vectors into rectangle components and how to use that method. Okay, bye.